We're starting the lightning talks right now, this very, very moment. If you're on the outside and there are seats inside, get up, move in. Thank you. I demand movage. I just have a quick announcement. If you gave a talk or presented a poster, you should have received an email from the illustrious Katie Huff earlier today about submitting your talk to a repository, SciPy 2013_talks on GitHub. Please do that. Thank you to Matt McCormick for reminding me to say that. Just a quick overview of the rules. So we are at 5 minutes for every talk. First come, first serve. If you aren't present when your name is called, you're going to be skipped. We're also going to skip repeats, or people who would be speaking for the second time. Sorry, Jake and Travis. You'll get bumped to the end, we are way overbooked for this event, so we will probably not reach the end. Yeah. What? Yeah. Cute. Do you want to give me a new? You can give me a new name very soon on the side here. All right. Well, without further ado, we're gonna have Alex present something.
Parakeet.
And Paul steal his biscuit. And next up is Matt Rockland. So please, Matt, come into staging here.
Okay, I guess this has to be very quick. I made 2 slides. So I'm Alex Rubenstein. I'm a grad student at NYU, and I've been working on another way to make Python fast. And they're kind of proliferating. There's quite a few of these things now. So it's called Parakeet, which is a very dumb name. I blame my project mate. We can use cute pictures of birds for our logos, though. Okay, so how does Parakeet work? You guys are now familiar with Numba, so that's great. I don't have to explain as much. It's very similar to Numba. You wrap your function with a function decorator, and then calls to that function are intercepted. The untyped representation of your function becomes a template, and when you call the function with particular types, the function gets type specialized, and then the specialized representation gets optimized, and we currently use LLVM to then generate native code. So I think this story is now familiar to everyone here. And every time you call the function with different types, you're going to get a new copy of that function generated as native code. Okay, so how's it different from Numba? One thing is that it is a very strict subset of Python. So Numba has these 2 distinct modes. It has full Python support and no Python. You can think of Parakeet as really just being a project that specializes in the no Python mode. And I actually think this is a much better way to go than trying to support all of Python because you get predictable performance. With Numba in the general mode, right now you get very shaky performance. Some things are 1,000 times faster than Python. Some things are slower than Python. And I don't think that's actually going to go away. They might push the boundary of which things run quickly, but I think it'll still be hard to predict. So I think that a no Python subset is the way to go, and that's what Parakeet is. And the other difference is that the way that I implement the NumPy functions that we support, which is a growing set, is I use data parallel operators. So every time you call a NumPy function, it turns under the hood into a map or reduce or an index map or this collection of operators that have somewhat obvious parallel implementations. And so that way you get parallelism for free without having to do anything very hard like analyze loops. So what's the status? It works. I've written a bunch of non-trivial programs. I have 1 user, and Craig K, if you're here, I'd like to talk to you. And so it's legitimate. It can do a lot. There's a lot of things that are missing. Most significantly, there's no garbage collector. So if you allocate arrays inside your code and they don't get cleaned up optimizations, you leak a bunch of memory. But it is quite fast. You can try it out. And if I have time, I will show something. Do I have like a minute? I can know how much time I've used. Okay, Here are some ways to calculate distances. You can do it a pretty way with comprehensions. You can do it the ugly way with loops. If you go down, you wrap that function with a JIT decorator here. And then you can do the same thing with number. And I have a comparison. OK, so both of those in Parakeet run fairly quickly. I ran these with 100,000 data points, vectors in length 10 against 10 clusters is the hard decay means. In Parakeet, this all takes less than a second. In Python, this takes forever. And in Numba, this takes forever. And it's not a slight against Numba, because I think the project's cool. And I think with no Python mode, they could get the same performance. But with Parakeet, you know when code's going to run, and you will know that it's going to run quickly. So that's the point of Parakeet.
Thank you, Alex. Matt Rockland is up next, and then I guess Travis is up after that if there's no one else.
Oh, no. Okay. Am I good to go? I'm apparently good to go. 2 seconds in. All right, my name is Matt. I'm talking about 2 things that I think are very obvious, which I like saying obvious things to groups of people that I like. So first one is group by. Second one is packages considered slightly harmful. I'm talking about why packages are bad. OK, so I have a principle. Principles are when you use something in many code bases, you should refactor it out so other people can use it. This is sort of a general concept of modularity, sort of a big idea. Again, this is an obvious thought. Hopefully everyone already thinks this. Oh no, wait a minute. Yes, okay, I love this. Okay, so this is my code, this oval. My code looks like this, it's very pretty. There's stuff I care about, which is the whole thing, and stuff that everyone else cares about, which is this small thing, because you guys don't care about the same things that I care about. So what do? I move it outside, and I import it. If there's one message in this talk, it's a please do this. Okay, please do this. You are a biologist. You have a gene sequencing thing that's really interesting to biology. Sure, I'm not a biologist. Part of your code is this fuzzy matching thing that's really interesting to me. Please do this. I want that fuzzy matching thing. Okay, that's what I want. So again, this is a good idea. We should do this. Okay. But inside this piece of code, there's actually like the really, really useful thing that actually everybody wants to use. Even web people want to use it. Okay? So you should do this again. Okay? And again, right? There's no reason to stop doing this. You should keep modularizing your code. Again, this is a principle. I'm taking this to absurdity. Thing that happens, though, is that when you do this, suddenly the intermediate packages become just a lot of imports. So that's fine. You can skip them. Okay? You skip the intermediate imports. Get rid of them. Again, you do this, it becomes absurd. You get lots of things on the outside. You've got no intermediate packages. You've just got a big package which just calls a lot of imports. Okay? I think this is great, actually. There's no rewrite of code. We've all written the same function so many times. And like the web people did the exact same thing, and they're the same code bases. So ideally, we never write code that repeats itself. And if you take this idea to sort of the absurd level, you come up with this, a bunch of tiny packages. Okay, I'm talking about my favorite tiny package now. It's a function called group by. Now again, you guys ideally have seen group by. It's in pandas. Maybe you've seen it in the pandas tutorial. It's an SQL keyword. Okay, but group by is also just a general function. Okay, so here I'm going to describe group by. Group by takes 2 things. It takes, first thing is a function. It's kind of weird. It's kind of like map or filter. And the second thing is a collection. So you have a collection of names. Alice, Bob, Charlie, Dan, all of our old friends. I have a function length. And group by takes a function and a collection of names, and it groups those names by their results under that function. So it's a dictionary, returns a dictionary that 3 maps to Bob and Dan. Okay, the 2 guys whose names have length 3. Takes Alice, Edith, and Frank to 5. Okay, so this is group by. Really general, useful function. Again, there's these 2 common functions, map and filter, which you've maybe seen before. Group by is sort of their cousin. Okay, really nice function. You've seen it in pandas. You saw it in the dined talk today. You've seen it in the SQL. It's also a general function. Great function. Here's a test which tests group by. Okay. Many times when you write code, you're actually just writing group by. Here's a histogram code. Turns out it's just group by with like an extra bit. Okay, so I've implemented histogram with group by. Okay. These are both implemented as gists because I have no other place to put them. There's no like package I can put group by in. Here's group by. It's implemented as a gist. It's a really simple thing. I use it everywhere. Actually, I use it everywhere. If you grep my workspace directory, you find group by implemented in every single util.py project and every single project I have. It's always there. It's written the exact same way. So think, OK, well, I'm going to put it in some other library, some utility library. Maybe I'll put it in a new iter tools. Right? Yeah, this actually exists. It's on GitHub. Please contribute. But group by is also higher order function. Maybe it's like func tools, okay? Or maybe it's like dict tools. Which one should I put it in? Right? Well, that actually makes sense. I can't put it in all three. I have to choose the intersection of the three. Okay, so group by needs to live on its own because it's just that cool. So you end up with is this. Which we're all laughing, but it's the only sensible thing to do. Little small functions. Please, please make little small packages, lots of utility things. I've got 9 seconds left. I've got some ideas. I'm going to run off the stage now. Thank you all.
Thank you, Matt, for overloading every other name ever. Next, we have Travis. Sorry, there was some confusion. He's actually going to be speaking on behalf of Elon. So, and then Matt, also overloaded name. Davis, please come up here next.
Congratulations to Elon.
All right, thank you. I did skip the one talk, so I'm only giving one talk. If I'd have known I only had one slot, I would have picked carefully what I was going to say. Please come to Schultz Garden. Continuum has a lot of things you're probably interested in. Come and visit, and we'll talk about them at Schultz Garden tonight, appetizers. So I wanted to talk today about, it's a great talk, Matthew. We're not up yet, so what's going on with the screen? All right. It's a Mac, of course. I can talk while the screen's coming up. So he talked about making many, many packages, which is a critical, I think it's a great. So all of software engineering has been done badly in the scientific ecosystem precisely because the packaging problem stinks. And I'm here to talk today, I think, about the work we've been doing at Continuum, I think, to help solve this problem. Conda has actually come a long way since last year, and it's a really, really great package manager, and you should just definitely take a look at it. And then today I want to talk about binstar.org, which is a new packaging service that lets anybody host their own repo in the cloud for free. So last year we introduced Anaconda. This year, Anaconda got installers for Mac OS X and Windows, many, many more packages. Anaconda Package Manager introduced. It is completely free for anybody to use, no matter who you are. Now the goal is to make everybody able to make packages. You know, we need many, many more Elon Schnells and Christopher Golkes in the world. We can yes, definitely clap. So, and we want to make deployment of Python solutions as simple as possible for everyone. So everyone can take advantage of these great tools very, very quickly. So the first thing to tell you about is Conda. If you haven't used it, you're not familiar with it, you really need to get to know it. It's BSD licensed, it's completely free, you can use it inside of anything else. It's independent of Anaconda, we simply use it to distribute and create Anaconda. It's a cross-platform equivalent of virtualenv plus yum apt-get. And together, it gives you this nirvana of package management, I think. It's not, you know, it's going to, you can take pull requests. We're happy to get pull requests to make it even better because it'll get better with time. But for example, the kind of capabilities it has, a SAT solver, dependency solver, satisfiability dependency solver, all the great package managers have them, now Conda does too. And recently, the newest release of Conda has a build command. So you take a recipe, and with Conda build, you build a new package. And then we've started that process by hosting a whole bunch of Conda recipes. We open source many of the Anaconda recipes. They're online, and we're going to continue that process. It just takes a little bit of effort to get them up there. So the thing I'd like to announce is Binstar. Binstar is Conda repos for everyone. This is a free service. You can go there. The beta code is Binstar in beta. It is still beta mode, so it's just getting started. But if you would like to essentially have your own private or company or organization repository that you are promoting to everybody else, you can create one in the cloud with Binstar. Public package management, it's very easy to use. There's a Binstar client as well as a Binstar login. And the other thing I want to talk about that's in Anaconda today is something called the Anaconda Launcher. Anaconda Launcher essentially takes packages that have an entry point and an icon and makes them applications that are deployable on anybody who has the launcher application on their desktop. So anybody who has the desktop points their desktop to a Conda repository, maybe yours, that you've advertised via the binstar.org, and they suddenly see your magnificent application showing up as installable in their location. An easy deployment for everybody through something like the Anaconda Launcher coupled with binstar and the Conda build command. These three things, I think, will allow you to take advantage of what Matthew just talked about. Let's make packages smaller, more dependencies, and then still get the word out for everybody. If you go to, there's 4 websites to take a look at, binstar.org, the Conda build framework description at the docs under Conda. It talks about exactly how to build a recipe. There's read the docs. There's a binstar client. You can go to read the docs and explain exactly how to use Conda to create a recipe and push it to the cloud. You use binstar. Binstar is just a simple, it's a command line version of the things you would do on the binstar website. That's all it is. The Conda is a package manager. binstar is a way to upload things. So you can see you can log in, configure, find out who you are. This is an example of cloning a repository that you might want to, it's just a directory on GitHub. You build a test package, it creates a package, and then the result is basically a gzip tarball, and you upload that via binstar as well. And then here at GitHub, under Conda recipes, it's a public package, public repository at Continuum.io. You can see a whole list of packages that are now available, and we'd like to see this grow. You can fork it, you can have your own. This could be a very community-driven world where everybody is shipping binaries and delivering binaries to as many people as possible. Thank you.
Thank you, Travis. Next up, we have Matt. And then in staging, we have Tony Yu, so please.
All right, thank you. I'm Jiffy Club, aka Matt Davis. I'm with Software Carpentry. If you haven't heard of us, we're a loose organization of volunteers that travels all over the world teaching kind of essential software engineering skills to scientists and engineers. And we would like to engage with every single one of you. There are a few ways we can do that. You can learn from us. We teach usually things like the shell, version control, programming, and unit testing, and other software engineering fundamentals, usually in a 2-day boot camp. You get in contact with us, say you'd like to host a boot camp. That means you find space, you get some coffee and cookies, and you arrange a little money, hopefully, to bring in, to cover the travel costs of the instructors that are coming in. And then we show up and teach you. And it's a great way to learn these fundamentals. You can teach for us. If you already know all this stuff and you want to give back to the community and help your peers, you can be one of us. You can be a teacher. You'll kind of enter this apprenticeship program. You'll help out at a boot camp. Then you'll be kind of an assistant instructor, and then you graduate to a full-on instructor, and you really get to run around the world, literally around the world. Just like this week, a couple of our people are in New Zealand teaching one of these, and you really get to teach them all of the tools that help you stay sane as a software developer every day. And you can even, if you don't really like getting up in front of people or teaching, it's not your thing, we have a lot to do outside of the classroom, working on our content. Literally our content, like editing and putting together the materials that instructors use in the classroom, coding up learning tools. I've written some, several other people have written just kind of packages that are accessible to novices, to people learning to code, to aid in the learning process in the classroom. So there's stuff to do there, just writing code. Our website, we can use help there. People who know HTML and CSS, especially people with good design skills, we would love to have some of you on board helping get things in order at softwarecarpentry.org. And there's always just way more of this. We have a lot of, as we've grown tremendously over the last couple of years, we have a lot of logistical problems that we can use help with. And the bottom line of all of this is that science wins. The skills we teach are the fundamental building blocks of open, reproducible science. And so teaching more people how to use version control, how to test their code, how to write their analyses into scripts can only help everybody and science in general. So please talk to me about contributing. If you're interested, you can go check out our website. You can follow us on Twitter. We're also on Facebook and Google+. You can send an email to info@softwarecarpentry.org if you're interested in becoming a teacher, if you're interested in helping host a boot camp, or if you just want to talk to somebody. That's a great place to start. Also, feel free to get in touch with me here. I have Software Carpentry stickers if you'd like one. And you can ask me any questions about this. I'm Jiffy Club on Twitter, on Gmail, Google+, everywhere also. So thank you, and I hope to hear from you.
Thanks, Matt, and don't forget to bring your lathe. Tony is next, and then after that we'll have Frances.
All right, so I am Tony Yu. I am a software developer at Enthought and a core developer of Scikit Image, and I'm going to talk about an interactive viewer for Scikit Image. The viewer itself is just a really, really small part of Scikit Image. This package actually has sub-packages for segmentation, for feature detection, measuring contours on an image, morphological functions, a lot more than I can talk about in 5 minutes. So I'm just going to focus on one small piece that I've been working on. This was actually started as a pull request by Guillaume Gay to add a line profile tool to Matplotlib as a Matplotlib viewer for Scikit Image. I ended up refactoring this into something called Scikit Loop, or Skloop, which is just a pure Matplotlib interactive viewer. Last SciPy, at the SciPy sprints last year, I rewrote this using Qt, it's for the windows and widgets, and Matplotlib for the canvas. And this allows you to just take advantage of the things that Matplotlib is good at, drawing images, lines, histograms, things like that. So the basic view is really simple. This is actually, So the basic view is really simple. You just basically pass an image to the image viewer and call show, and you get something that looks like this, which is not that amazing. The whole purpose of this viewer package is to really make interacting with Scikit Image functions very easy. So what you do to do that is create plugins. So this is an example of a plugin. Everything up top you can kind of ignore. They're just imports. The important parts are that you have this filter function that you connect to. So here we're connecting to the canny filter to this plugin. And then you connect some widgets in order to control that filter. So the canny filter has a sigma parameter, which you can adjust, low and high thresholds that you can adjust as well. And there's the connection there. And then you just add this plugin to the viewer. And that's all you need to do in order to interact with this function. If you don't like, if this is a little too much boilerplate for you, and you want to look at very simple functions, then you can use this alternate syntax, where you just initialize the plugin with that filter, and then literally add those widgets to the plugin itself. And so let's just take a look at some examples. So this is that canny filter example that I just showed you. If we run it, then you can interact with this function, and you can get an intuition for what these parameters do to the function. A couple of more tools are implemented in this viewer. The original pull request by Guillaume Gay added this line profile tool that allows you to measure the intensity along a line. And you can actually change the thickness of this line to change the area over which you're averaging. There is a color histogram. So last year at SciPy, Darhas implemented a lab color space. So that basically takes this image and plots it in a different color space, which is shown here on bottom. This is the histogram. And you can actually select regions in order to isolate and segment regions of this image. Let me just close that one. Okay, and here is an example of watershed segmentation. So watershed segmentation, you basically write some labels and you propagate those labels. So here I'm going to label some coins with different colors, and then the background a different color, and then run the segmentation algorithm that gives you this. The most recent addition is viewer linking. So here is an example where I create two different plugins. Ooh, this is not the right example. This is an example where I create two different plugins, the Candy plugin that I showed you earlier, and a Huff line transform plugin, which basically just draws lines. But the important part is here, on this line here, I pass an image to the image viewer, or sorry, up here. But on this line, I pass a plugin to the image viewer. And so what that does is it gives us this image that we're familiar with here, but also gives us this other image, which is actually connected to the results of this image. So that's cool. And then what we can do is use that image as the result of this second plugin. So this is the Huff line transform drawing lines. And if we update the original view, we can actually affect what happens in the later view. All right, so I am running out of time, so I just want to say thanks to Stefan van der Walt, the BDFL of Scikit Image, Guillaume Gay for his original pull request that started all this, Steven Sylvester for reviewing some of my PRs, all the Scikit Image developers and contributors, and I want to invite people to sprint with us tomorrow. Thanks.
Thank you, Tony. I ignore my imports too. This is Frances.
Thank you.
Matt Terry is up next.
So, this doesn't work. Okay, so my name is Francesc Altet. I work for Continuous Analytics, and I would like to introduce you to BLSeed, which is a component of Blaze for doing fast input-output. So some few words about Blaze. It's an environment for storing, operating, and analyzing large data sets. And it leverages LLVM technology for on-the-fly code compilations. And BLSeed is as a component of it that is kind of a native format that allows to store big data sets efficiently. So this is a schema on how Blaze works. We have the data descriptor that is kind of a buffer interface. You can think about it like this. So the data descriptor gives access to different data sets, formats, either in memory or either on disk or on distributed machines or whatever. And then the data descriptor handles different data buffers to the Blaze execution engine. And using the LLVM infrastructure, all these buffers are operated with and returned back to the data sets for the storage again. So here is a layout for BLSeed. We have the data set is expressed in directories. So the root, hanging from root, there is a meta directory. This is metadata about the actual data. And then the data is, directory contains a series of superchunks. And these superchunks has the BlockSpack format that has been designed by Valentin Heinel. It should be sitting somewhere there. And then each superchunk is composed of a series of chunks, okay? So that provides a lot of flexibility to us in order to distribute the different superchunks in different machines for distributed purposes. And the storage, it's important to say that the storage can be either on disk or in memory, this storage. So why did we invent it? A new format file when the world doesn't need another format file at all? Well, we are trying to push the machines towards its limits. So we absolutely needed a new format in order to take the advantage, the most advantage of our resources. So BLSeed is specially designed to allow to extend existing data sets without implying a copy, like for example in NumPy. So what does BLSeed is to just to take the new data that has to be append to the existing data sets and just compress it and just update the metadata in order to add it to the existing data set. So you may ask if compressing is not going to hurt performance. Well, the quick answer is that it depends. It usually helps a lot for when you're doing I/O to disk. And there is nothing fundamental preventing memory access going faster either.
So let me show you a small benchmark. For example, let's create a NumPy array with 50 million of elements, and let's store it in a Blaze array, in a VLC array. Okay, so we can see here, well, I have problems with my, but the original data set has 388 megabytes, and the compressed size is only 86. So the compression rate is 4. So here it's a typical way to store that in NumPy, in memory, using the MPSID format. This takes 4 seconds. And this is the time that it takes to store the same file, the same array, but using VLC in memory, which is 4 times faster by doing compression. And also for doing the deserialization, MPSID takes almost 2 seconds, and NumArray VLC takes less than this. Okay, so it's very efficient. So if you want more information about Blaze, just go there and give it a try. Okay, thank you.
All right, so we next up have Matt Terry.
So, hello everyone. I too am Matt. We're on your third Matt for the lightning talks. Just want you to know we have 3% Matt concentration here, which is awesome. I'm really hoping next year for 4 or 5. So if any of you have friends that are also named Matt, you need to bring them next year. I think there are more women than Matts. That'd be terrible if it weren't. So I'm going to talk about yoinking data from published figures. So I have a nemesis. It is not equations. I can deal with equations. I can deal with PDEs. It is not my department printer, scanner, copier that you may have heard about from last year, or the lowly QR code. It is, however, Professor mantis shrimp. Cool. Interesting thing about mantis shrimp, they see in like 17 colors. Not 3 colors like we do, RGB. They see in like 17. Consequently, they publish figures like this. So there's all the information for dealing with this is in the figure, right? You have a color bar here, and you have lines on the axes. All the information is here, but that's obnoxious. So I wrote a tool called Yoink to yoink the data out of this. So this is platform independent. It runs on top of Matplotlib with widgets, so it'll run anywhere. So this is the figure I pulled in. I've just yoinked this out of some paper someplace. And I have this color map extractor. And so this gives me 2 views on the data. The first, so I can select my color bar, which is here. And notice this is kind of a wacky color bar. There's 2 areas that are sort of green to the eye, but the actual data is real. And so notice this updates live, and we'll crop the image. So we'll bring the sides in. Being a little fast and loose because it doesn't matter for a demo. My demo will hopefully work. And we come over here, and we can fix the scale because that's important, that your data actually is right. I'm making up numbers. And there's a dump button if you really care. But this also works in a notebook. So up here, I created this thing to pull the data out. And now I'm going to pull the data out. And you can see there's a dictionary with all the data. And now I can plot it again. And this time I've used a reasonable color map. This is the GIST color map that shows you mountains on one end and low in the end and blue at the other. This is actually the Yosemite Valley. That's right there. That's Half Dome, and that's at Hetch Hetchy and whatever. So this is actual data, and this actually looks like a topo. This is reasonable data. And just to show you how ridiculous this particular color map was, it's a knot. So if you look at this, it starts at one end, and it wraps around itself, and this is a knot. And it was able to deal with this. So hopefully sane data that you get in real life, it will be able to deal with. So I hope you find this interesting. So there's also a widget for dealing with lines. It's not as humorous, but you can. But it too works. It's there. All this is up on GitHub. Those are deep fried mantis shrimps. So we've solved the problem. We have fried the shrimp. Up on GitHub, yoink. I'm looking for work, hire me. So, thank you.
Not to be topped, the ever-present Terry. Well, thank you, Matt. That concludes our lightning talks. We do have a couple of announcements about social events. So we have the Continuum IO happy hour at 7:45 at Schlotz, is that correct? And then the Women in Scientific Computing at 7 p.m. in the private dining room 1 that's down in the restaurant. And then the WiseIO people are going to make a very quick...
I'm Jamie Eads with WiseIO. We're building a collaborative... We're building a collaborative framework for to democratize machine intelligence and machine learning. So we have a very fast and scalable infrastructure. Our implementation of the very popular random forest algorithm runs faster on a Raspberry Pi than the scikit-learn implementation on a MacBook Pro. So if you don't believe me, you can see for yourself. Come to our happy hour at 5 p.m. at Schultz Garden. And unlimited free beer, as much as you can drink in an hour. Thank you very much.
And then we have one final announcement from Stefan about the proceedings.
Hi, everyone. So those of you who participated in the proceedings before might have known that we have a bit of a dubious history. This year, things are much better. On that laptop lying on the chair is a first version of the proceedings. And it exists. So if you want proof, go to Stefan, it's my name, stefan.pythonanywhere.com. Just to give you a quick idea of how we worked with these proceedings, people submitted pull requests on GitHub. Comments were made by reviewers on the pull request, so everything is out and open. You can see the changes the authors made to the paper as they collaborated with the reviewers. And so everything is out there for you to see. I merged the last pull request, and I will push out the proceedings today. But the PDFs are available at stefan.pythonanywhere.com. That's our build server, so check it out. And thank you for all of you that contributed. Finally, if you find any bugs, please file a pull request against the proceedings. I'll keep it open for a week or so, just so we round it off properly. Yeah, thanks.
All right, so let's enjoy the rest of the evening.
I got to have something with it.